It is, as always, a massive privilege to be part of any event. And I just want to say well done to everybody's build and everybody's contribution to this event so far. It's been fantastic. And I just want to thank Willie and Joe, especially, first of all, for, measuring me up there to be worthy of taking part and presenting a session on the live stream. And also, thank you for all the effort that you guys put in for this event and to make it possible this year. Everybody that's a fan of Lego and a fan of the event, I'm sure appreciates it as much as I do. But as always, yeah, it's a massive privilege to be part of this event. Yeah, I'm gonna maybe just introduce a little bit about myself before I actually start with the presentation. I've been a fan of Lego for most of my life. I think I was about 4 years old when I received my first Lego sets. And my collection just sort of grew from there. And when I turned 7 for my 7th birthday, I received my first Technic set from my parents. And that is where I think I got hooked on Technic. It was the number 6 go-kart set. And it had some functionality to it. And I was just blown away about, with how it made Lego just that much more awesome by creating actual working functions into it. And I don't think I really bought or received many other system sets after that. It was mostly Technic from then. I remember my father brought us some Technic sets from London at some point when he had to go. They've traveled there for work. It was really awesome to receive those because those sets were not available in South Africa at that time. And yeah, the bug just bit me, and I entered a competition or two when I was fairly young, which I really enjoyed taking part in. But my interest in Technique just grew from there. And when after school, I never really had a serious dark ages area that a lot of other people say they had. In my high school years, I didn't get that many sets, but I still tinkered with the Lego sets. And after school, I traveled to London, or I stayed in London for 2 years, and started earning my own money. And you could start afford buying Lego again. And since then, it just continued. I bought some of the newer sets. The studless Technique sets started coming out, and yeah, my interest just grew more and more and more. And I made friends through my work with Ian Kuchlenberg. You guys know him in Zalak. He's also one of our members. And he used to build Meccano. And I sort of showed him what I was building with Lego, and he showed me what he was building out of Meccano. And he got a bit frustrated with, what he can build with Meccano compared to what we can build with Lego, and the accuracy of Lego and the complexity of gearboxes that you can build with Lego, that he eventually decided, listen, man, he wants to change. And he sold most of his Meccano and ended up buying quite a nice variety of Lego sets, and also mostly Technique. And he was the first one of us to actually find Zero Lug as a club. I always talked about it. I always said, man, yeah, I wish there was a Lego club, or that I can join and share my interest with Lego with. And I didn't really. I'm not very. I'm quite a technical person in mechanical wise, but not very technical and big on social media and those sort of things. So I don't really frequent Facebook and all the social media sites very often. So Ian came across Zero Lug, and he joined Zero Lug before me. And I was still working on the offshore oil industry, so I was away from home very often. So I couldn't really attend any of the meetings and things to join the lug. But then I just decided, listen, man, I need to do it, and I want to do it, and that's how I got to Zero Luck, and it's just been fantastic ever since. So yes, I really enjoy being part of the Luck and to share my love and my interest with everybody else. So yeah, that is me in a nutshell. With regards to my Lego interest, I mainly build mocks. I do not really. I don't really build sets. I like the challenge of figuring out a mock and building the different aspects of a mock. I do like to build some of the new Lego sets, especially the technique sets that Lego releases, just out of interest sake to see, listen, what was their idea behind a new part that they released. Sometimes they've got an interesting mechanism that they include in their build or their design. And we all learn from that as well. But generally I build technique, and I build mocks, and I also have a real big interest in GBC. Now, like we've all said before, GBC is sort of the place where things really rock. And for those of you that know, and as part of the GBC group, you know that you need to be involved with your display the whole day, because you've got moving things, you've got balls flying all over the place, and you've got a lot of interest from the public as well. So there's a lot of questions, and you need to attend to the build very often. So because the GBC sort of display is normally separate from the different, from the other displays where there's more stationary builds, you know, I stopped building mocks that is just a standalone model, and I sort of concentrated on building GBC mechanisms for quite a while. And then I thought, but you know, I'm still missing building the nice big mocks, you know, of a nice machine or a you know, crane or a truck or something. So Ian and I had the discussion and said, listen, man, we need to build mocks that is it can be a standalone model, but you can integrate it into a GBC display. So you know, that's what we started doing this year. You know, we built the nice bridge, which is a nice display of structure and dealing with forces, because especially with the span, it's got about a 2 meter span. But we integrated it into the GBC circuit so that it's just a simple runoff, but people can still appreciate the nice design and build that we built. And that's also what I did with the Dragon that I built for the GBC circuit. It's part of our special project display that we did this year, which we will still do at a later event and probably do a proper video footage of that. But you know, I really enjoyed building the Dragon, as it is a very nice display model. It's got a lot of organic features to it. It's got moving parts to it, but in actual fact, it's just a very over-engineered slide for the bulls to run down. But it helps me to integrate that build into the GBC circuit where I'm at most of the time at a display. So it allows me to participate with the public and interact with them and answer the questions and see their reaction while I'm part of the GBC circuit and my build is not standing somewhere else at a table where I'm not attending. So so yeah, that is a bit about how I build and what I enjoy building. So on that note, I'm gonna start sharing my screen. We are going to talk about implementing movement into your builds. Now, for a lot of people, this is quite a challenging aspect, because generally Lego bricks are not made to move. They're supposed to lock into each other and form shapes, and it's not the easiest thing to implement movement into your builds. So today we're going to just discuss a few things about movement, different mechanisms, and sort of try and cover this just so that, you know, try and motivate everybody that's interested in doing this, you know, to at least start to do this, because you know, you want to learn somewhere and you need to start somewhere, even if it's the most basic form of movement. you know, because it just makes, and we've seen it from the GBC displays. You will have people literally spend an hour or two at the display, standing and watching all the different mechanisms move. And it just takes that awesome model that you've built just to the next level and just makes it more awesome. Say, yeah, man, that is really fantastic. I mean, if you can see some of the entries that some of the builders did in some of the past videos we just watched, the moment you see movement, it just makes it a little bit more awesome. And so yeah, that's something I enjoy doing a lot. I want to always build a mock and then try and integrate movement into the mock as much as possible, so that it just brings you that extra wow factor. Let me just see if I can, there we go. So what we're going to talk about today, our topics, we're just going to discuss our 6 simple mechanisms and what they are, especially according, you know, in the world of physics. We're going to discuss how do these machines get applied in real life? Where do we see them, these simple machines? How do we convert these real life mechanisms into Lego mechanisms that move or create movement in our builds? How do we plan for it? What type of mechanisms are available? Then we're going to talk about steps and tools to use when designing mechanisms, how to make it easy, you know, easier and less intimidating. I'm also going to discuss a couple of things on common mistakes when building moving mechanisms, things that I've seen people do, reasons why movement fails or why it doesn't work as well as you would have liked. And then if anybody's got any questions, we will discuss some questions and answers if everybody's interested in to do that. So what is a simple machine? A simple machine is a mechanism or a mechanical device that changes the direction or the magnitude of a force. Now, you have many different types of forces in nature. You've got gravity, you've got wind forces, you've got physical pushing forces, we've got mechanical forces from engines. Now, if you have a mechanism that changes the direction or transfers that force into another different mechanism, it creates a machine. And in physics, there are 6 classic simple machines that sort of defined by the Renaissance scientists. And these are a lever, the wheel and the axle. The lever creates leverage, wheel and axle creates movement around a single point and transfers loads. Pulleys also changes the direction of a force and gives you mechanical advantages. You get an inclined plane that changes the altitude of an object, or gives you gravity advantages, or gives you a braking force if you go up against a inclined plane. You get a wedge force that splits a piece of material apart, for instance, an axe or even a knife. A knife is another form of a very narrow wedge if you want to cut through something. And then the screw is another classic example of a simple machine. The screw is used to drive certain forces in certain directions, and it's also used to keep different components together if you drive a screw through different components. So on this page is just an example, or just images of the different types of simple machines, and just displayed in a more visual example of what the force and the mechanism can do. These mechanisms basically form part of almost every single mechanical mechanisms or machines that we encounter in our daily life. Literally in every single thing that we have, you will find if you revert back to the basics of the movement or the basics of the force, you'll find that this mechanism is in that actual design. We're going to look at first, just as the basic to understand the physics of movement. An example of a mechanism that we're all familiar with is a bicycle. Now, a bicycle is made up of a combination of quite a few of these different simple machines. First of all, you have the wheel that refers to the basic machine of a wheel and an axle. So you've got a wheel that turns around a center point, and that allows the bicycle to move forward over the terrain at a reduced friction. Then you also have the gear mechanisms, the pedals. The gear mechanisms is another example of a more advanced wheel, and we'll discuss the gear just a little bit further now. The pedals is an example of the lever that transfers the force of the person onto the wheel or the gear, the ring gear itself. You have brake levers that again is an example of transferring force through the brake system onto the wheels. You've got the handlebar, and that changes the direction of the bike. So combining these different simple mechanisms make up a more complicated machine. So if we look at the gear, for instance, a little bit closer, it is a wheel that moves again around a center axle, and but the gear itself is a little bit more advanced. If you look closer at it, I think it's on my next slide. The little teeth of the gear is actually little levers that forces the chain around the ring gear. So again, that's a form of leverage or a lever combined with a wheel that creates a more advanced machine. Going back to the previous slide, the lever itself again is transferring the force through the wheel, through the chain to the back wheel, a combination of different machines. But why are we talking physics? You know, when we actually want to talk about building Lego. Now, it's just to understand, just to explain, because it forms part of the thought process when planning and designing a moving mechanism. Because at the end of the day, there are some mechanics and physics involved. I mean, we stay on Earth. There is gravity involved. We need to plan it properly to implement the right mechanism. Now, in our life, we have many different mechanisms around us that can inspire your thought process. I mean, we've got analog clocks, we've got kitchen appliances, we've got electric toothbrushes that has got a gear system in it, even the flushing mechanism in your toilet. I don't know how many people has actually removed the lid in your toilet bowl to actually see what that mechanism looks like. But that is a more advanced version of the lever. The handle on the outside transfers the force to the mechanism on the inside of the toilet, and it releases the water to flush a toilet. Now, that again is a simple mechanism, but it might be something that you can implement or initiate the idea of a mechanism into your build. So you wanna look at things around you when you start planning something, and you know, to be inspired by machines around you. And we've got these simple machines around us everywhere to start building a moving mechanism into your Lego build. So again, the question: so why are we getting a physics class when you want to talk about Lego? So the simple answer is that when you want to make Lego move, you need to understand the basics about physics. Everything, there is an input force that initiates the movement, and that force gets transferred through a mechanism to your end result, the part that you want to move or create movement for. So we need to understand the type of force that'll make the element move in the direction or the way that you want to move. I mean, do you want the part to spin around? Do you want the part to move up and down vertically? Do you want to be able to move it in a horizontal direction? And you need to consider how fast or how slow do you want this mechanism to turn or to move? And then how strong does the force need to be to move that part that you want to move? If you are building a very small, a mock with a very small part that is moving, the force that you need to turn that little part is not very big. But if you are building something much bigger, you need to create a bigger force to transfer that initiating force to the actual part that you want to desire, that you want to make turn. So then finally you need to ask yourself, do you want to make this movement happen manually or automatically? Is it something that you want to interact with your hand by turning a little lever? If you turn the lever, the mechanism moves, or if you push it up and down, there's a lever that moves the item that you want to move. Or do you want to make it automatic by just switching on a little Lego motor or an EV3 program, and that motor then transfers the force to the mechanism and moves it automatically, or at a timed program or at timed intervals, and however you want to make it design into your build. So these are the questions you need to ask yourself when planning a build. Now, this is where it comes to a very important part of the build, and that is the planning. And the same as Wayne and Paul has mentioned, the planning part is very important. And I find that, you know, when you get an idea, you tend to get very excited and you just jump into it straight away and you start putting parts together. And like everybody, you know, get to a point and you think, but man, how can I make this build even more awesome? And at that point, that's when you realize, but hang on a second, maybe I can make this part move. And in most cases, that is where things go pear-shaped. Because it's almost a last moment thought, and it's not easy in most cases. In most cases, it fails to try and implement a complicated moving mechanism into a build or a mock that you've already done. Because many times you have to take it apart completely, or you haven't allowed for enough space in your build, or structurally you didn't allow for a supporting structure for your moving mechanism, or you haven't allowed the correct space for gears to mesh up correctly, or you don't have enough space for a transfer gearbox that reduces the speed or increases the speed or the torque, the force drive on the motor. So when I build, or when I start planning a build, I first think it through properly. I also do a couple of quick hand drawings. I use Google for a lot of reference material as well. I tend to build mechanical mechanisms, which ends up being cranes or earth-moving equipment. Generally, because that's more of the industry that I work in, and it's sort of an interest that I have in. So there's a lot of reference material online. So I download images. I try and get technical drawings of the actual mechanism or the build that I wanna do, to try and determine my scale. And then I start. You know, and then you need to decide what part of your mock do you want to make move beforehand. You know, you can't plan, well, you can't add it afterwards, because you need to build a supporting structure that is strong enough to be able to carry the mechanism itself. You need a structure that integrates it into your build properly. And then you need a structure that is strong enough that can deal with the forces that is generated by the movement. Now, we've seen it many times with some of the GBC builds that we do, that when you start making things move, it tends to want to pull itself apart. So if you don't make the structure strong enough, and ensure that the structure cannot pull itself apart, you're going to have a fail, especially if you're building something for a display that sort of needs to run the whole day. And you know, parts tend to wear out over time if it runs the whole day. And there are methods that you can make sure that you try and reduce friction, to try and make your parts last longer, to eliminate friction completely, and to also make the structure stay together. So planning is an important part. And again, you don't have to use fancy software, especially for the more simpler builds. But I'm going to go through some of the steps that I do when I plan some of the complicated builds. Now, generally, I do a quick hand drawing first. I saw Joe, he took some of Wayne's advice, and he did a scribble quickly on a page here for his next big build that he wants to do. Sorry, these are a couple of examples of moving mechanisms. Sorry, before I get to the planning. These are just some gears driving another gear. This is an example of gears moving through a differential that changes the direction of an input force into another direction at a 90-degree angle. Here we've got a cam gear mechanism that works on a timing. So it changes your move at a 90-degree interval on this specific build. On the next one, there's an example of a helicopter that when you pull the little lever on the side, it actually uses centrifugal force, and the blade continues turning. Here we've got a nice example. I got this from Brother Brick. It's one of the reviews they did on one of the Jurassic Park sets. It's got a simple lever mechanism that reveals a hidden chest in one of the caves, or one of the mountain volcanoes little scenes. So it's such a simple mechanism, but it just makes that build so much nicer by implementing that. So there are many different types of ways you can implement movement into your mock. And the thing about it is, because there are so many different ways of doing it, it's very difficult to explain to you, say that there's only one way of doing this. And we all know with Lego, there's not just one way of doing this. There are many, many ways you can implement movement, and many ways to drive it, many directions it can come in from. And that's where you need to really just understand first what you want to do. And that is where the planning part becomes essential. So this is Joe's master plan for his next epic build that he gave me. So yes, yeah, for instance, you can see there's quite an epic fight going on there, and he might want to make the arms move between Luke Walker and Darth Bacon, and make the lightsaber fight more epic. But I mean, this is how basic you can start. It doesn't have to be very complicated. It doesn't have to be professional drawing. You need to give yourself a guideline, just to an overthought of where do you want certain parts to be, what do you want to actually make move before you actually start completing the design for your entire build. Now, again, I reference images of if I want to replicate something that is available in real life, a big crane or a ship or a construction piece of construction equipment. Or I will, if I want to build something more organic, like the dragon, I decided on that, listen, what do I want to make move? So I decided, listen, I want to make this model posable. So I made all the joints in the shoulders and the elbows and the ankles, I made that movable. They are movable manually by turning some actuators and gears, and it keeps it in position. But for instance, the chest cavity, I wanted to sort of simulate the breathing of the dragon. Sorry, I don't have footage of that here now. You'll see it on the video when we're showing the builds that we did for the actual competitions. But the idea was to make it look like it is busy breathing. And so I built actually a very simple CAM mechanism that sort of simulated the movement of the chest, and the side ribs just hinged on a lever, and that created the movement. But because of the complexity of the build itself and the scale of it, the structure needed to be very strong to be able to deal with all the forces that is spread out through the build, because it's so big. So, and again, even after building so many years, I changed the plan sort of halfway through the build, deciding, listen, man, I can actually make this chest move. It wasn't initially part of the idea, and I was sort of playing around prototyping the model, and the prototyping went so well that it ended up morphing into the final build, and I didn't really build that many prototypes that I normally do. Now, that's something else I want to talk about is prototyping. Now, prototyping can be something as simple as building a very simple layout that sort of resembles the size of what you want to build. I generally build my prototypes in part colors. Now, this is maybe a tip you can use. I tend to build it in colors that I'm not planning to use in my actual mock. Now, the reason for that is when you build a prototype, you develop a mechanism or a structure, and as you build it, you might want to fine tune it. And so when you start building more complex prototypes, you end up using quite a lot of your parts. And if you build it in the color that you're going to actually end up using in your mock, you might not have enough parts in that color to actually build your mock. And you have to start taking apart your prototype. And when it's a complicated prototype, and if you haven't drawn it in Studio or LDD, you start losing the plan that you did because you don't have the example in front of you anymore. Now, on a simple build, it's not that complicated, but on some of the more complicated builds that I tend to end up building, it's not that simple just to build it from memory again. When you practice and you build certain mechanisms, you will find that the same as what Wayne and Paul do, they have got certain sort of templates and mechanisms or systems that they use in almost all their builds, so they have a general idea of, listen, how does this mechanism or this method or this technique work? I know how it works. This is how I implement it in my next mock. So when you more experienced with building more of these mechanisms, you know that, listen, if you're building a gearbox that needs to transfer force, either increase the speed or decrease the speed, this is how I would do it, because you have a standard that you almost use every time. It's very easy to change that design a little bit so that it's integratable into your build itself, but the basic design already exists, so you don't have to build a prototype for that anymore. Because at the end of the day, there are only so many mechanisms that creates movement. You either have a motor that drives a couple of gears in a direction, or you have a motor that drives gears to change the direction of the force, or you have a scissor mechanism that works on a moving lever that moves up and down. I'll show some examples of that a bit later. That'll give you up and down movement, or you've got a cam piston type of movement like on a locomotive that gives you forward and backwards or up and down type of movement. So it's actually fairly simple that almost all movement that you want to create at the end of the day ends up sort of going back to the same basic mechanical mechanism. And some of them just needs different gear ratios to increase or decrease the speed. We'll talk about that a bit later as well. Some of them you want to reduce the speed for a specific reason. You don't want to make the thing fly apart. You want to have movement in a specific direction or only a certain length. So you need to play with gears and the length of levers and the rotation of cams and pulleys that give you that limitation. You know, do you want a short back and forth movement, or do you want a longer back and forth movement? So you need a longer lever or a longer cam that creates a bigger circle that will give you more movement at a time. So the prototyping is very important. What I do with this prototyping is, you know, out for instance, you know, measure, listen, this is more or less where I want my input. I know this thing is going to be more or less, you know, from the scale that I've sort of determined from my my reference images. I would determine a scale in Lego, and I'll talk about that just now. You know, how big do I want to build the mock? But I use a simple piece of structure just to give me a size indication of how far do I want the input drive and the output drive far apart, because you need to now link these two somehow. And you know, this will also be determined about, you know, depending on what you're actually building. You cannot always put the motor directly at the output drive. Now that's the simplest thing. If you can connect your motor directly to the part that you want to move and you just want to make it spin very fast, it is simple enough if you want to hide it. But in most cases, you cannot do that. The motor is not always something that is supposed to represent the mock that you build. You only want the movement side of it. So you need to transfer the force that is generated by the motor through a simple mechanism and have the end result of the movement. So just quickly a little bit on scale. I've had a couple of people ask me in the past, how do I determine the scale that we build something in? Now, you need to think about your build. There are certain aspects of your build that you need to consider. That is something that is true to the model, that represents the model in real life. So if you are building a big front end loader, for instance, one of the biggest components on the front end loader is either the shovel in the front or its wheels. Now, generally in Lego, we only have a certain amount or certain different sizes of wheels. And it's not an easy thing generally to build, especially if you want to make the model playable. You can build wheels, but it's not very strong or sturdy. So the moment you start moving the mechanism or the build around, the parts will fall apart. So you are sort of forced to use the wheels, for instance, in any type of vehicle. So you need to go and measure or find a drawing that tells you, listen, this is the size of the wheel in real life, and then go and measure the size of the wheel that you have and say, okay, this wheel is 3 centimeters big in the Lego scale, but it is 120 centimeters big in real life. So you take the 120 centimeters and you divide it by the 3, and you get 1 to 40. So you know your scale is 1 to 40. So then everything that you measure on your drawing, if a drawing says the total length of this thing is 4 meters, if you want to find out how how big that is in Lego scale, you just divide the 4 meters by the 40 and you'll get your scale size. And you can literally take a ruler and take that measurement and say, okay, this is the length I need. So then you can go and take bricks or Lego beams, Technic beams, and you can measure how many studs does it make up to reach that length. And that'll then determine the size of your scale. Many other things you need to discuss and consider as well is just strength as well. Structure wise, will my scale be able to deal with the structure and the force that is in the structure? And also, will you be able to do you have enough bricks for the scale? Because that's one of the biggest problems that I tend to have, is I tend to want to go quite big with my builds because I like to include a lot of detail and a lot of movement. But I find very quickly that, listen, even though I've got quite a significant Technic collection, that I always need more parts. So that's one of the curses of building big things, is that you're gonna end up buying more parts, or reduce your scale if you want to. I need to move along. So build a simple mechanism, a prototype. You know, that's quite if it's very important in your planning. That'll give you an idea of, listen, where do I need to transfer the force? How big does my mechanism need to be? And then you can build that into more detail. You can scale it to what your mechanism what'll make your mechanism fit into your actual mock itself. Then another fantastic tool is the digital software that we have, either LDD or Stud.io. I also used to draw in LDD, and a couple of years ago I moved over to Stud.io. I just found that because of the scale and the number of bricks that I end up having in my build, the processing power of Stud.io was just a little bit better, and you can. The renders are very professional and in high quality, and it also helps you to generate instructions. So when you build these type of mechanisms, it's always nice to create your steps on the side. I'm not going to go into too much detail of that now, but as you build along, so that even for yourself at the end of the day, when you have to recreate this in real life, you don't have to go and pull this thing apart digitally. You can hide certain parts, but you need to plan the process of how do I put this together, because you can take one of these parts and literally pull it through something else, but in real life you cannot necessarily do that. Certain parts interact with each other in a certain way, so you need to plan that part as well when you're using digital software. And the other thing that I've found is something you need to consider is you cannot always feel the structure strength or see what the structure strength will be when you're building digitally. You have, it'll look nice, but the moment you build it in real life, it's very floppy or it's not strong enough. And so you need to take that into consideration as well. So some of the biggest problems that people do, or mistakes that they make when they build these type of designs or mechanisms, is that you fail to plan first, and then you don't support your structure properly. And we've seen that a couple of times, and I've specifically noticed it in some of the guys' builds in the latest season of the Lego Masters in Australia. Some of the guys built these awesome mocks and sort of decided, they want to make a portion of it rotate or lift up and down, and they didn't put enough planning into their design. And when they built the moving mechanism, it was very flimsy, so it pulled apart very easily. And for instance, on this example, if this was all that was supporting this mechanism, eventually this gear will work itself off the axle, and the force created between these two gears will actually pull apart these two bricks from each other, and that'll stop the gears from interacting or meshing properly, and your movement will stop. I've got an example here of one of my gearboxes that we use as a standard in some of our GBC modules, and this has proven itself very reliable. You can literally see every single gear is supported from every side. The gear cannot move in any direction. It is literally surrounded by structure. Every open space on the axle is filled with something, so that the gear itself cannot move anywhere. The structure itself is designed in such a way that these two gears cannot pull apart because it's connected in one technique lift arm, and the two sides cannot pull apart because it's held together by this supporting structure on the side. So when you're designing a mechanism like that, try and design it as solid as possible. You know, support the axles and the gears on both sides, and test it. That is something else that fails a lot. You know, that creates fails. You need to test your mechanism. Run it for a couple of minutes at first, then try and run it for a couple of hours and see what it does. Does it start pulling apart? Try and build your mechanism so that there's the least amount of friction possible. You know, don't squash the bushes too tight against the structure. That'll create extra friction. Try and move the gears away from the side of the structure, because these gears actually touch the side of the structure a little bit and causes extra friction. So if you can move these gears away from the structure that's supporting it, you remove that friction immediately, and you'll have a very reliable gearbox or mechanism that'll not give you any problems. But planning, build prototypes, make sure you support your structure correctly, and test it. Those are the four main aspects of designing a mechanism into your build. So just a couple of quick things on gear ratios. You can find quite a lot of information. I think this table was actually created by a very well-known technique mock builder, Cyril. It gives you the relation of between the different gear types and gear sizes. If you were to combine the same gear, it'll give you a 1-to-1 ratio. So that means the input speed, if you put one rotation into the driver gear, you'll get one rotation out in the follower gear. If, for instance, you use this gear to the smaller one, you'll have one rotation of this gear will give you 3 rotations of the smaller gear. Now, again, this is not something that you need to try and calculate yourself. There are tools available. Again, Cyril was, he made some very nice apps that we can download. I'm not exactly sure. The last time I checked, it wasn't available on the App Store for the Apple iPhones, but it's available on all the Android devices. So there's an app that calculates gear ratios for you. So you can literally select your driver gear and your follower gear, and it'll tell you the gear ratio that you need. And I'll show you an example. If your driver gear is small, your output and your follower gear is large, you reduce your speed. Maybe I must just quickly show, I'm just gonna stop sharing for a moment. Our very good friend Ian built this very amazing mock of different types of moving mechanisms. And if I switch it on, so he was gracious enough to lend it to us. So if you see here, sorry, it might be making quite a bit of noise. The gear, okay. So here you have a small driver gear with a large follower gear. So you will see the speed is quite slow. Here you have the driver gear is large and the follower gear is small. So you can see between these are exactly the same two gears, but they just swapped around. Your speed is significantly increased on this one. But again, there's a sacrifice. When there's speed, you can actually stop it quite easy with your finger. But when it's slower, so you have less torque or less force. When it is slower, you have more torque. I cannot stop this with my finger. It just continues turning. So there's a few different examples of combinations of gears here. He's also got a example of a lifting mechanism here that works on a lever and a scissor lift. And then on the side here, he's got a couple examples of a cam mechanism or like a locomotive piston that will give you up and down movement. Now again, you can see they're moving fairly fast, but you can reduce that speed dramatically by implementing a gearbox. There's a mechanism that he built for us that shows side-to-side movement, and that side-to-side movement actually activates a gear to only turn at certain times. So that might be a type of movement function that you would like into your build. That is an example of how our gear ratios influences your build. And you can play around with that, and also you can use different motors that has got different sizes. Lego makes quite a few different size motors that'll either give you different speeds or different torque values. And again, Cyril made an awesome app with the Lego motor specs, and it'll give you exactly your RPM and the size of the motor, the type of torque that you can get out of it, and a very, very helpful tool when designing a build. You can also change speed by the different control mechanisms that we have. Like, for instance, if you use a speed control or remote control through a infrared sensor, you can adjust the speed. That's actually one of the simplest way of doing it, and to control your speed or even the direction you want your build or your movement to turn into. Those are some of the tools available. Again, you know, we've got many talented people in the different lugs, and I'm sure most of them are always willing to share information and share skill and help out if anybody gets stuck. I know I've had a couple of people that approached me with certain things that were difficult to figure out, and we were able to figure out something together. And it's really nice to implement movement, and you must not be intimidated about it, you know, and everybody starts at the same place. You know, you start from scratch and you build up skill over years of practice. Today, even I build prototypes sometimes 12 times, 16 times before I'm happy with a mechanism, whether it's structurally right, or the size is right, or the output force or speed is correct, or the shape of it is correct. You know, don't think because you failed once it doesn't want to work. Try again. Look at different technique sets or Lego sets. A lot of movement is already built in there, and it gives you actual steps how to build. You can take that portion out of the build and implement it into your own mock. So yeah, that is basically the sum of what I wanted to share. In a nutshell, there's a lot more to say about this, but again, our time is fairly limited. But anybody's always welcome to contact me. If they have any questions regarding movement, I can always assist, and I'm sure there's some of the other guys always willing to do that as well. For our Lego builders, we are always very interested or very attentive to detail. I've got a question. I've got a question that'll give you an answer, and you can win this prize. Attentive detail. There was one slide in my presentation that did not have my Lego Man logo, Lego Man RSA logo on the bottom corner. So the first person that can guess which slide that was can win the set. So it's a nice little set. I'm not exactly sure what the slide number is, but I know what slide it was. So we need to just tell me what slide or what was on the slide that did not have the logo on it, so you can win that prize.
So we've got the bicycle. Many people are answering the bicycle. We've got Joe's picture, cog and chain, the bicycle, gear ratios. Did anyone get it yet?
No.
Keep answering.
So yes, while we're waiting for the answers, Cyril has also released an official, unofficial Lego Builders Guide to Lego Technique.
and he really shows a lot of nice detail in it, discussing different mechanisms, how to put together different gear ratios. That book is available in hard copy as well as an ebook. And he's got a very nice practical way of explaining the basics of it. And sometimes he discusses a little bit of history about how the part was designed and older parts versus a new version of the same part, and how different parts interact with other parts in that way.
Of course.
So jump in here.
So that's also a nice reference to do. So
is it on the page where my drawing was?
No, it's not that one.
No, I haven't got it yet. Yeah.
All had logos.
No.
And it says it's on the one without the bigger on, of course.
Okay, so it looks like we don't have that many
Gear rotation charts.
Nope, not yet.
I did see it there. I want to venture a guess, but I think I'm wrong. It's on the small gear and the big gear.
No, it's not that one either.
Scott Chapman, who wants to win again, says the cover page.
No.
Person riding a bicycle.
Nope. So what did we talk about today? What was the other than movement? We discussed something that is the basis of everything.
Ian Gearbold. I know what it is now. Physics, machines, structure, physics, the gear ratio sheet, basic machines.
Okay, the basic machines. So the six basic machines are examples of the 6 basic machines that not have the logo on the bottom of the cord.
Nice.
All right, well done, Vanessa.
Congratulations.
It's there with Eben, and we've got this to give away as well.
Yes, so I don't know if we've got time for many questions, but if anybody have any more complicated questions, they're more than welcome to contact me. Like I said, I'm not a very big social media addict, so you're welcome to either contact me on WhatsApp directly. Most of you guys know me through the log. You're welcome to give me a call or send me email on legomanrsa@gmail.com, and I'm more than willing to help you guys implement any movement into your builds if you need any help. But thank you for the time. Thank you for the opportunity to chat with you guys. And again, well done on everybody's work for Brickfair. It is really awesome. Thank you very much.
Yeah.